Alright, let's look at the homework 3.4, problem number 8. Alright, so we want to first to find the derivative of this given function here. Alright, so let's do that. Alright, so we're going to take the derivative, maybe with respect to x, of course. In this case, here y prime is equal to. We can probably just use the quotient rule. Before we do that, we can just, since you have a 10 is just a constant multiple, we can just put 10 outside, and then just worry about taking a derivative of 1 over 1 plus e to the negative x. Right, so let's do that. Right, so 10's already outside, so we already took care of 10. Then we can just take the derivative of that. Let's go ahead and do that. Actually, I'm going to do one more step here. So I can probably write this guy as 1 plus e to the negative x to the negative 1 power, because it's a reciprocal, right? So all you have to do is put negative 1 in front, right? Then keep the inside function as it is, and then subtract 1 from the power, so that's going to be negative 2. Then multiply by derivative inside. So derivative of 1 is 0. Derivative of e to the negative x is e to the negative x, but you have to multiply by derivative of negative x, which would be negative 1. Alright, so you can cancel negative right in front and a negative 1 here. And then I will probably write it this way. So you have a 10 on top. Right, so I'm going to put that 10 on top. Right, then we have e to the negative x on top as well. So I'm going to put e to the negative x on top. And then on the bottom, we're going to have, because of the negative power, we're going to have 1 plus e to the negative x on the bottom. So I'm going to put 1 plus e to the negative x on the bottom. And then we'll still have to square that whole denominator there. So I'm just going to put the square there. Right? So that will be the derivative. So let's type it in. Alright, so we got, what was it, 10 e to the negative x all over quantity squared 1 plus e to the negative x. Alright, so we have that. Alright, let's check the answer. Alright, I came back and we have, looks like we have the correct derivative. Alright, so let's find an equation of the tangent line to the curve at the 0, 5. Alright, so since 0, 5 is a y-intercept, so we already know, since we have 0, 5, which means that the y-intercept usually use b, we already know it's 5. So we just need to find the slope. So slope m is going to be, right, so derivative of that, so y prime, then we just have to plug in 0, right, because x1 is 0. So you have 10 times e to the 0 is 1, so you have a 10 over, right, 1 plus e to the 0 is 1, so 1 plus 1 is 2, 2 squared would be 4. Right, so we can simplify, so it's both even numbers, divide by 2, you get 5, divide by 2, you get 2. So it looks like slope is 5 halves. Right, so by slope-intercept form, we know that the equation is going to be y equals 5 over 2x plus b is 5. Right, so let's type it in. Alright, so we have y equals 5 over 2x plus 5. Alright, let's check the answer. All right, I came back and looks like we got the equation of the tangent line correctly. All right, part B is just finding the correct picture. So y-intercept is 5, so we can eliminate the first one. And then this is okay, and then we can eliminate this one. So it's going to be either second one or the fourth picture, right? But the slope is 5/2, which is a positive, so its slope should be, its tangent line should be going up like this. So we know that the fourth one is the correct picture. All right, let's check the answer. All right, I came back and it looks like we got the correct picture. All right, that's it. I hope that this was clear.